In this lesson, we move into special right triangles. Okay, so we're going to take a look at some triangles that you already know about, and we're gonna relate the angle measures and the side ratios and the angle measures with sine, cosine, and tangent. Try to come up with some patterns here. So special angles come from special triangles. Our special triangles that we're talking about are isosceles right triangles and an equilateral triangle. They're drawn right in your paper there. So we're just using the front page of your paper here to come up with some things that you'll see, and we're going to kind of summarize at the end and what they're for. But an isosceles right triangle has a 90-degree angle, because obviously it's a right triangle, and then it's because it's isosceles, it has two congruent sides. Well, if it has two congruent sides, it must also have two congruent angles, and obviously one of them can't be the 90, because you can't have 90 and 90, that's already 180, so that's too many. It's got to be these two angles here, so both of these angles must be 45 degrees. So that's why an isosceles right triangle is a special triangle, and that's why 45 degrees is considered a special angle, all right? So what we're going to do is we're going to come up with the sine of 45 degrees, the cosine of 45, and the tangent of 45. Remember, it's all ratios. These are all just ratios. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. That's all these are. It doesn't matter how big the sides are. So let's just say this was 1 and 1. Okay, if this side is 1, this side has to be 1. If this side is 2, this side has to be 2, right? Well, you ever hear something called the Pythagorean Theorem? Well, the Pythagorean Theorem would give us the third side. Well, if this is 1 and this is 1, 1 squared plus 1 squared equals c squared. That's 2 equals c squared. And then we take the square root and we get the square root of 2. Okay? So this would be the square root of 2. If this was 2 and 2, you'd have 2 squared plus 2 squared equals c squared. You'd have 8 equals c squared, and you'd take the square root, and you'd have 2 radical 2. So this would be 2 radical 2. But guess what? Everything was multiplied by 2. Now we have, you don't have to write this, we'd have 2, 2, and 2 radical 2. Everything just got multiplied by 2. So by making the sides bigger, there's no point in even doing that. So what we're going to do is just say 1, 1, and radical 2. Again, where did the radical 2 come from? It came from the Pythagorean Theorem. We could make these bigger. It doesn't matter. We know they have to be equal. So what's the sine of 45? Well, sine is opposite over hypotenuse. Opposite over hypotenuse. So here, let me set this up. Here's my right triangle. Here's my 45-degree angle. Here's my opposite, 1. And here's my hypotenuse, radical 2. So it's 1 over radical 2. And then we rationalize that by multiplying by radical 2. Remember, we can't leave a radical in the denominator. And we get radical 2 over 2. That means that the sine of 45 is radical 2 over 2. That's kind of hard to understand, but that just comes from the isosceles right triangle. If I did it with this one, if I did it with multiplying everything by 2, if I had 2, 2, 2, it wouldn't be any different, because I would have 2 over 2 radical 2, and the 2's would cancel out anyways. If I had 2 over 2 radical 2, wouldn't that be the same thing as 1 over radical 2? So I'd still have 1 over radical 2, and 1 over radical 2 is 2 radical 2 over 2. So we're going to do cosine of 45 now. Okay, so the sine of 45 is radical 2 over 2. Cosine of 45, adjacent over hypotenuse. Okay, I'm going to put these back to 1. I'm going to put these back to 1 and make this radical 2. Cosine is adjacent over hypotenuse. Adjacent is this side right here. So again, that's 1 over hypotenuse, which is radical 2. So I multiply by radical 2 over radical 2, and again I get radical 2 over 2. So the sine and the cosine of 45 are both radical 2 over 2, and the tangent of 45 is opposite over adjacent. Here's the opposite, which is 1, and my adjacent is also 1. 1 over 1 is 1. So again, the sine of 45 radical 2 over 2, the cosine of 45 is radical 2 over 2, and the tangent of 45 is just 1. We're going to summarize all that on the next page. You can flip over there now. Here's 45. The sine of 45 is radical 2 over 2. The cosine of 45 is radical 2 over 2. And the tangent of 45 is just 1. We're just summarizing what we do over there. Equilateral triangle. That's another special triangle, and we get more special angles. What are the special angles? Well, in an equilateral triangle, because the angles add up to 180, if they're equal, 180 divided by 3 is 60. Therefore, each angle in an equilateral triangle must be 60. So 60 is a special angle that we're going to be studying. Also, if I draw the altitude, meaning I just draw a line straight down the middle of the equilateral triangle, what happens? Well, I cut this angle up here, and I have a 30-degree angle now. This is still 60, and what's this angle here? So we're going to ignore this, and we're just going to study this triangle right here, which is another right triangle. This is called a 30, 60, 90 right triangle. 30, 60, 90. These are my special angles. 45 from above, 30, 60, 90. These are all special angles. They all come from special triangles. Okay, so I have a 30, 60, 90 right triangle, and I'm going to try and study from that. Okay, so I'm going to do this again. If I had, I'm going to do this for this one. I'm going to make it easier. I'm going to go 2, 2, and 2. We're going to say all the sides are 2. Because again, it doesn't matter. I could do 3, 3, 3. I could do 4, 4, 4. I could do 5, 5, 5. As long as they're equal, it's an equilateral triangle. So I'm just 2, 2, 2 is going to be the easiest to study this right triangle that we're creating here. So this is 60. This is 30. Here's a 90. 90, 60, and 30, of course, is 180. Okay, so we're going to ignore this over here. This is 2. And, of course, if I cut the 2 in half, it's 1 and 1. So now I'm coming up with this length right here. So let me redraw that over here. I have a right triangle that's 60, and then 30, and then 90. I have a 30, 60, 90 right triangle. This length is going to be 1 because it's half of the base. This length is 2 because it's the full length of the equilateral triangle. And I need to know what the height is. What's the altitude? What's the altitude of my equilateral triangle? Again, Pythagorean Theorem, but C is the 2. So it's a squared plus 1 squared equals c squared. A squared plus 1 equals, c is 2, sorry, 2 squared, which is 4. I'm going to subtract 1. I'm going to get a squared equals 3, and I'm going to take the square root. So I have the square root of 3. Square root of 3 is going to be that altitude, that height of the equilateral triangle. Now we can study the angles 60 and 30 in relation to sine, cosine, and tangent. And here they are. So what's the definition? Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. You got to make sure you do that. So we're going to do 30 first. Here's 30. Opposite is 1. The side is the opposite. 1 over 2. So my sine of 30 is going to be 1 over 2. Again, that's opposite over hypotenuse for the 30-degree angle. Here's my 30-degree angle, opposite over hypotenuse. How about the cosine of 30? Adjacent over hypotenuse. Radical 3 over 2. And how about the tangent of 30? Opposite over adjacent. 1 over radical 3. And then I got to multiply by radical 3 because I can't leave the 1 over radical 3. And I get radical 3. I get radical 3 over 3. So now we've come up with the sine of 30, the cosine of 30, and the tangent of 30. And we're going to put those in our chart on the next page. The sine of 30 is 1/2. The cosine of 30 is radical 3 over 2. And the tangent of 30 is radical 3 over 3. So we are going to have to memorize all these, and I know it sounds like a lot right now, but once we work with them, it's going to become a lot easier. Let's do 60 now. Here's the 60-degree angle. The opposite is radical 3. The hypotenuse is 2, so I have radical 3 over 2. The cosine is 60 adjacent over hypotenuse. That's 1 over 2, adjacent over hypotenuse, 1 over 2. And then tangent of 60, opposite. So here's the opposite, radical 3 over adjacent 1. So it's radical 3 over 1, and that's just radical 3. So the tangent of 60 is just radical 3. So I'm going to fill in 60 now. The sine of 60 is radical 3 over 2. The cosine of 60 was 1/2, and the tangent of 60 is just radical 3. And that all comes from the special triangles. All right, and again, this is going to be, you're probably going to come to class like, what the heck were you doing, Mr. Ventry? I'm just giving you the background on how we're getting these ratios. What your job is going to be is to memorize all these. And you might think like, oh my God, how am I going to memorize them? We're going to talk about it. As I work with you in class, we're going to find a way how to memorize these. Last thing is just an example, some examples here. Determine the exact value of cosine 120. Well, remember 120, I'm going to draw 120. Here's a 0, right? We did drawing angles. 120 is right here. All right, remember we did reference angles? So I'm going to draw a right triangle. And I know if this is 120, my reference angle is 60. So 120 has a reference angle of 60. So I'm really doing cosine of 60. And I'm in the second quadrant where cosine is negative. Okay, cosine is negative. So it's negative cosine of 60. So it's going to be negative 1/2. Because it's negative cosine 60, and cosine 60 is 1/2. So it's negative 1/2. Now we are doing, here we are just doing, I'm going to block the chart out, but all these come from the chart. All these are going to come from the chart above. Sine of 60 is radical 3 over 2. Again, that's right up there. Cosine of 30 is also radical 3 over 2. And now we're going to multiply. Radical 3 times radical 3 is 3, because it's radical 9. And then 2 times 2 is 4, so we get 3/4. So these are just operations with the ratios that we just learned. Cosine of 45 squared. Cosine squared 45 means the cosine of 45 squared. So the cosine of 45 is radical 2 over 2. We need to square that. And then the tangent of 30 squared, that's radical 3 over 3 squared. So that's going to be 2 over 4 plus 3 over 9. And then we're going to get a common denominator here. All right, so we need a common denominator in order to add them together. So we're going to multiply 9, 18, 27, 36 we can go to. So we're going to go to 36 times 4 times 4 times 9 times 9. And so this is going to be 18 over 36 plus 12 over 36. And that's going to be 30 over 36, 5/6. 5 over 6. And then this one here is radical 2 over 2 squared minus, and then tangent of 45 is 1 squared. So this is going to be 2 over 4 minus 1 over 1. 2 over 4 minus 1 over 1, we got to go times 4 times 4. 2 minus 4 is negative 2 over 4. So that's going to be negative 1/2. All right, so there it is. I know that I kind of flew through that for you, but I didn't want to take any longer on the video. Basically, you memorize these sine, cosine, tangent of 30, 45, and 60, and then you can plug in and do the math. Basically, you're multiplying and adding fractions, which we've done obviously before. All right, so I'll see you in class to practice these skills.